In this video, I'm just going to demonstrate how to complete the Excel requirements for question 2 in the week 7 quiz. So the first part is B. You just asked to complete some values up here. So B1 is the intercept coefficient, that's 45 in the model that we've been given. B2 is the second coefficient, -3 is the third coefficient. The expected value of the error, that's the mean of the error, that's 0. And the variance of the error is 25. Its standard deviation is the square root of that. I'll just show you that you can use there is a square root function in Excel that will do that for us if it's not such an easy calculation as this one. Okay, so that's B done. Part C says it requires us to simulate a sample of 55 observations on Y, and part I of C says randomly generate a sample of 55 error terms in cells D13 to D67. So to do that, we are going to use data analysis, and then random number generation. We only want to select one sample here, and we're asked to do select 55 values. The background tells us that the error terms are normally distributed, so we'll choose the normal distribution. The mean is 0 and the standard deviation is 5, and we're specifically asked to output this starting in cell D13. So hit OK and OK again, and our values have been generated. Now part 2 says use the equation of the data generating process, so the model. The x values that are given, so that's those ones there, and the values that you just generated for the error term to calculate y values. So that will be equal to, each y value will be equal to, in the model, the intercept plus the coefficient of the first explanatory variable times its value, plus the coefficient of the second explanatory variable times its value, plus the error term, and that's the calculation of the first y value. Now, as I drag this down, I'm going to want to, it's going to go across multiple rows, but I want to keep the references to these rows where my coefficients are locked in. So I need to put a $ in front of all the B references here. So in front of, not that B, sorry, only the coefficients, that one. And yep, that's it. So the ones that I've left $ out of are referring to the ones specifically in this row, which I do want to float or be relative references, so that as I drag this down, those values will change, or those references will change. So I'll hit enter, just copy it down one cell, double click on that cell to see what the formula is doing. It's referring to the coefficients that I want it to, it's referring to the values of the explanatory variable and the error that I want it to, so it's working fine. Now I will copy that down to the remaining values here. And as for question 1, I'll make sure that I get the same font size to ensure full marks are awarded. Okay, so that's part C completed. And the last parts, well, the next part that requires Excel is part E. That's our old favourite, estimating a regression model. So what we've done is simulated a sample from a known population model, whose parameters were these ones up here. And what we now want to do is see if we estimate the population model based on this sample, do we get something that approximates the model of the data generating process that we actually used. So to run the regression, it will be data analysis, regression, okay, choose our Y values, which are here this time, choose our X values, so we've got two explanatory variables, highlight them both. Labels, I did include headings then, confidence interval, the next question asks about a 95% confidence interval, but Excel provides this as a default anyway. I'll change it to 95. And we're not asked to output this anywhere specifically, but it might be handy to have it in this worksheet. And H2 looks like it'll be fine. So I'm going to hit OK, and there's our regression output. And we can take a quick look at, based on this simulated sample, what our estimated coefficients actually look like compared to the real parameters. So those three are estimates of the regression coefficients. They're all pretty close. And our other main parameter is the error variance, which is that one there, fairly close to this 25. If we look at it, the square root of that, so the standard error, it's even closer, 5.2, 5.3 compared to the population model of 5. And for F, we were asked about a 95% confidence interval for B2, so that would be this one. You can see Excel generates this one as a default, the 95% confidence interval, so that's the lower end, that's the upper end. And I manually said, give me a second 95% confidence interval. As you'd expect, it gives me exactly the same values. But if I wanted a different interval, as you saw with question 1, I could have specified this was 99% or 90%, and it would have given me different values to the ones that were there. Okay, and I'll leave answers to the remaining parts of question 2 to the written solutions.